All right, let's finish this thing off. Going back to problem number 2. The reason I skipped this one is because it's a growth, and I wanted to show you a growth and a decay back to back, so we're coming back to a compound interest formula, which is a growth, all right? So this is the very advanced one where you can get different types of compounds. Now, normally we just do this yearly, annually, once a year, but here's the formula that can show you ways to compound your interest multiple times throughout the year. So here's all the bits and pieces. Okay, so A is going to be the balance. That's what you're going to have after all of this math gets done. All right, so let me read it out here. You go P times, in brackets, 1 plus R divided by N. Close, close the bracket, take it to the N times T power. What? Here's what you do. This number right here, that's going to be your starting dollar amount. That's how much you put in the bank initially, your starting initial amount. It's called the principal. R is going to be the interest rate. Use a decimal. That's how much the bank's going to pay you. N is going to be the number of compounds in 1 year. There's lots of different flavors of number of compounds. There's quarterly, which would be 4 times in a year. Quarter, 4 times in a year. There's monthly, 1 a month, that's 12. Semi-annually would be twice in a year, and then bi-monthly is every 2 months, like a bicycle, every 2 months, so 6 times in a year. There's lots of other flavors. I've heard of, we did quarterly. I'm trying to think, I think there's sometimes there's like weekly or bi-weekly. There's lots of different flavors. There's one that does it 3 times in a year. That'd be like a trimester type thing. I don't know. There's lots of different flavors out there. But again, friends, it's just a number. The most commonly ones that we'll use is quarterly and monthly, I believe. I know that my savings account compounds it quarterly. So every 3 months, I get a little bit of interest paid to me. So, and then T is going to be the number of years. All right. So what you do here is you actually get paid interest more times, but it kind of weakens your interest rate. So we'll spend more time talking about that in class, but here's just the basic formula for now. All right, so put things in the right place and then have the calculator do the work for you. Here we go. So here's the example. We're going to put $2,000 in the bank at 4.5% interest quarterly for 18 years. I know there's a lot of math there, so here we go. So here's what we put in the bank, right? So I'm going to start there. Put $2,000 in the bank. Bracket 1 plus. Now, 4.5%, what is that as a decimal? That's going to be 0.045, okay? And I'm going to divide that by how many times I'm going to get interest that year. Quarterly, that's 4 times. So I'm going to divide by 4. So what it does is it kind of weakens my interest rate by 4. Since I'm going to get paid 4 times, they're going to kind of weaken the interest rate by 4. But then I'm going to get it compounded 4 times. So right away, if you divide by 4, write a 4 right up here. Then how many years go by? 18. There we go. So all you get, it's just a puzzle. It's literally just a puzzle. Put the numbers in the right place and you're going to be fine. All right? So again, the tricks are, you got to put the decimal there. You got to divide by the number of times you get it in a year. That kind of weakens your interest rate if you get it compounded quarterly, but then you get 4 times as many paybacks or interest rounds go by, so to speak. All right, I'm not probably using the technical terms, but you understand what I mean. So this whole thing, you can basically type in your calculator one big swing. So I'm going to give that a try here really quick. So I type it like I see it. Here we go. $2,000. Turn it on first. Here we go. Got a nice little glare. It's awesome. Here we go. $2,000. Slide this over a little bit. $2,000. Bracket 1 plus 0.045 divided by 4. Okay. Close the bracket, and I'm going to take that to the power of 4 times 18. Okay, everybody kind of see what I did here? 1 plus the interest rate divided by 4. Order of operations, you're probably, wait, yeah, don't worry, that'll divide first, so I'm fine there. And then take that to the power of 4 times 18. So again, you can just type the whole thing out, see what we get here. After 18 years, we got $4,475. Near a cent would be 53 cents. So there we go. So it was 4,475.53. There we go. Again, all I did is put numbers in the right place, and then I just did math, okay? I think there's an extra question, okay? It says, well, what if you did the exact same thing, but then you did it monthly? Okay, so basically it's going to be the exact same thing. I could use the exact same part, the exact same calculation, but instead of a 4, I'm going to swap in a 12. Okay, so monthly would be 12 times a year. Every month you're going to get an interest rate. You might get a little bit more. What it does is it weakens your interest rate by 12, but you get 12 times the amount of payback, or you get 12 times the amount of installments. So you lose some, but you get some. So hopefully we'll make a little extra money here. Let's go ahead and see here. $12,000. Bracket 1 plus 0.045 divided by 12 this time. Close the bracket. Take it to the power of a new bracket. 12 months and 18 years. See what we got here. Ooh, made a little bit extra cash there. Look at that. Looks like we got about 14 bucks, 13 extra bucks. Nice, not too bad. So monthly doesn't change a whole lot. Get a little bit of extra money though. Again, this was just an initial investment of $2,000. If you were to keep putting money in the bank, it would keep on growing. It's usually a good idea. Near a cent, 1 cent. There you go. Okay, so that was just compounded monthly. All I did is I took out the 4 and I put in the 12. Did the exact same calculations there. Sorry, it's getting blurry on me. But that's it. Put things in the right place. Let the calculator do the work. All right? That's all I got, friends. See you in class. Goodbye.